Hello everyone, today in this video we will be discussing the second module of 18MAT41. Okay, in this module we have a part of transformations. We have three transformations, and in the second part we have bilinear transformations. We have some numericals wherein we will be finding the bilinear transformation and variant points. Okay, we will be looking at various examples, and in the third part we have the integration of the complex functions along with two proofs. Okay, so we'll be going through each topic one by one. So if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, and let's move on to the first topic, which is discuss the transformation of w is equal to e power z. Okay, so this equation is given to us, w is equal to e power z. Firstly, you need to write down what is z. Z can be written as x plus iy. Okay, so if z is equal to x plus iy, what will be e power z? E power z can be written as e power x plus iy. When you separate it, you will get e power x into e power iy. Okay, and then you have to use this formula, which is e power theta is equal to e power I theta is equal to cos theta plus I sin theta. Okay, this is the equation, cos theta plus I sin theta. In case you have minus I theta, you will have cos theta minus I sin theta. Okay, by using this equation, you will be separating the real part and the imaginary part. Okay, real part will be e power x cos y, imaginary part will be e power x sin y. Okay, so nothing, the first step what we did is substitute the value of z in the given equation and then separate the imaginary and the real parts. And after that, what we have to do, you have two cases here. We have the x term here and the y term here. So we'll have two cases. In the first case, we'll be eliminating the y term, and then in the second case, we'll be eliminating the x terms. Okay, so after that, in each case, we'll be drawing a graph. Okay, now see, to eliminate the y term, what we can do is, if we square it and add it, at that time we'll have cos square theta plus sin square theta, that will be equal to 1. You'll be remaining with the e term here, which is e power 2x. Okay, now if you eliminate the y terms, you will have u square plus v square is equal to e power 2x. If you take e power 2x as r, at that time you will get u square plus v square is equal to r, which is nothing but the equation of a circle. Okay, and similarly, to eliminate the x terms, what you can do is divide v by u. When you divide v by u, you will get e power x cancelled, and sin y by cos y is nothing but tan y. Okay, so when you shift u in the other side in RHS, you will get v is equal to u tan y. This is the equation of a straight line. So we have two equations here. In the first term only we have x terms, in the second only we have y terms. Okay, so by using these two equations, we will be drawing the graphs for each of these. Okay, so in the first case, x is equal to constant. In this equation, if you substitute the value of x as c1, you will get e power 2c1, which is a constant value, and take it as r square. So this equation is nothing but a equation of a circle in the w plane, having the origin at the center and the radius r. Okay, that's it for the case 1. In the second case, we'll have y as constant. So v is equal to tan y into u. Take it as constant. Tan c1 can be taken as m. V is equal to mu. This is the equation of a straight line in the w plane, wherein the line will be passing through the origin. Okay, so you have two equations here. First one is for a circle and second is for a straight line. By using these two equations, we'll be drawing the graph at the same plane. Okay, so the first in the z plane, you have the, when x is constant, you will have this line. When y is constant, we will have this line, and corresponding to that, we have, which is a circle and a straight line. Okay, in the w plane. This is all what we have to do in the transformation of w is equal to e power z. Okay, moving on to the second one, we have w is equal to z square. Do the same thing, take z is equal to x plus iy and substitute the value here, and then separate the real and imaginary parts. Now by looking at this, we have to eliminate the value of x in the first case, and in the second case we have to eliminate the value of y. Okay, how can we do that? By taking x is equal to a value c1, we have to substitute the value of y in the second equation. See, if you take x as c1 here, just keep y in the RHS and shift this value in the denominator. You will get y as v by 2c1. Using this value of y, substitute here. Here you will be using the value of x as c1. Okay, so you will be getting the equation in the terms of only c1. Okay, and the equation, when you simplify, you will get the equation as v square is equal to minus 4 c1 square into u minus c1 square. Okay, so this is the equation which resembles the equation of y square is equal to minus 4ax. This is the equation of a parabola. Okay, now three things you need to know to draw the graph of a parabola. First one is, you need to know it's symmetric to x-axis or y-axis. Okay, see, this is the parabola here. It can be either of this form or this form, or in the x-axis, or in the negative x-axis. Okay, so you need to know which type of graph it is. Firstly, remember this point, wherever square is not there means in x square is not there, so it will be symmetric to x-axis. Okay, wherever square is not there, there it will be symmetric to. Okay, so the first point is it's symmetric to x-axis. Second one, even if it's symmetric to x-axis, we need to know it's coming from negative direction or positive direction. For that you need to look at the coefficient, it's minus 4ax, means it's coming from the negative side. Okay, and where it will be intersecting is the third point. You have to see in the equation u minus c1 square, it should be of the form x minus something. Okay, that value will give us the point where it's intersecting. Okay, so in our case it is c1 square. Okay, so the graph will be looking as follows. It will be coming from the negative axis and it will be symmetric with respect to x-axis, and the point of intersection will be c1 square. Okay, similarly in the second case we have to take y is equal to a constant value, substitute the value of x as in the terms of y in the second equation, find the parabolic equation. We will be getting v square is equal to 4 c2 square u plus c2. Now the 3 points are, the first one is it symmetric with respect to x-axis or y-axis. See here we have v is considered as y and u is considered as x. Okay, so here v square is there but u is only having the power of 1, so it will be symmetric with respect to u axis or x axis. Okay, so that's the first point. And the second point is it coming from the positive direction or the negative direction? See here we have its 4c2, that means its positive value, that means it's coming from the positive direction, and the point of intersection will be u plus c2 square. See, it should be of the form x minus something, so if we take c2 as minus c2 square, at that time we'll get the point as minus c2. Okay, so there it will be intersecting at minus c2 square. Okay, our graph will be as follows, coming from the positive direction, symmetric with respect to u axis, and having the point of intersection as minus c2 square comma 0. Okay, so this is the graph for y is equal to a constant value. Okay, observing the given equation, we have been given w is equal to z square, so it resembles the equation of a circle as well. So we have to consider a third case where the value of z will be r. Okay, the value of z is r, wherein the graph will be of a circle in the xy plane, and we have to find out the corresponding graph in the w plane. Okay, for that consider the equation z is equal to r e power I theta. This is the standard equation you have to memorize, and taking w is equal to z square, we will be squaring at the RHS, we will get r square e power I2 theta. Take r square as capital R and 2 theta as phi, so we will get the equation w is equal to capital R into e power I phi. Okay, so that's nothing but a equation of a circle in the w plane having the radius r square, which is a capital R, and the angle as 2 theta, which is phi. Okay, so this is the equation of, so this is the graph of the circle in the z plane corresponding with w plane. Okay, coming to the third one, which is w is equal to z plus 1 by z. Take z is equal to r e power I theta. See, you can take z is equal to x plus iy also, but in that case it will be hard to find out the graph. Okay, so in this case it will be easy. Let's look how. Substitute the value of z in this equation, it will be r e power I theta plus 1 by r e power minus I theta, when you shift e power I theta in the numerator. Okay, now this equation can be written as e power I theta cos theta plus I sin theta, e power minus I theta cos theta minus I sin theta. When you separate the real and imaginary parts, at that time you will have u as r plus 1 by r cos theta and v as r minus 1 by r sin theta. Okay, now we have to eliminate two things. In the first case we have to eliminate theta, in the second case we have to eliminate r. Okay, so how to eliminate theta? What we can do is, since we have cos theta and sin theta, we will be keeping cos theta and sin theta at the RHS part and shifting the remaining terms in the LHS. Okay, so we will have u by r plus 1 by r in the first case is equal to cos theta. Similarly, we will have v by r minus 1 by r in the LHS part and sin theta in the RHS part. What we can do now, we can square and add to eliminate cos square theta plus sin square theta. Okay, when we square it and add, we will get the terms u square plus r plus 1 by r square plus v square by r minus 1 by r whole square, that's equal to 1. Okay, this is our first equation. In the second equation we have to eliminate r. So what we can do is, we can keep the r terms in the RHS and take the theta term in the LHS. Okay, so you will have u by cos theta and plus v by sin theta. Okay, that will be squared and added. Okay, let's see what we will get when we square and add. You have to square and subtract. Okay, we have to when we square and subtract, at that time we will get r plus 1 by r whole square minus r minus 1 by r whole square. If we separate it, we will get the terms r square and 1 by r square here, that will be eliminated by minus r square and minus 1 by r square, and the remaining term here is 2 into r into 1 by r. Here we will get minus of minus 2r into 1 by r. Okay, so r and 1 by r will get cancelled and we will have 2 plus 2, which is 4. Okay, so we will get 4 in the expansion of this equation. So we will get the equation in RHS as 4, that we will be taking in the LHS part in the denominator. So we will have u square by 4 cos square theta minus v square by 4 sin square theta, that is equal to 1. Now we can consider 2 cos theta as A and 2 sin theta as B, so that you will get u square by A square minus v square by b square is equal to 1. This is a similar equation of which we can form a graph very easily. Okay, so let's see the first equation which you got. This is the equation u square by, this can be considered as A and this can be considered as B. Okay, so you will get u square by A square plus v square by b square is equal to 1. In the second case, u square by A square minus v square by b square. The only difference is that in the first case it is plus and the second case it is minus. Okay, so you will have two graphs. For the first case, when it is plus, it is an equation of ellipse, so we will draw an ellipse in the w plane, and similarly in the second case we have minus here, which is the equation of hyperbola. Okay, so we will draw a hyperbola in the w plane, and similarly you have to draw the graphs in the z plane as well. When theta is constant, at that time you will get a straight line. See, when theta will be constant, it will be same for all the points in the plane, so you will get a straight line here. And in the first case, it's r is equal to constant, so you will have the value of r as same while theta will be changing. Okay, so you will get a circle in the first graph. Okay, so this is all what you have to do in the transformation of the given equation. So what you will have to do is substitute the value of z as x is equal to z as x plus iy or r e power I theta, okay, according to the given equation. Then after that, separate the real and imaginary part, and then take one of the term as constant and draw the graph, and take the other term as constant and draw the graph for that as well. Okay, so let's move on to the second part of the module, which is bilinear transformation. Okay, before that, let's recap what are the values of z and w, which is z is x plus iy and w is u plus iv, where u and v are the functions of x and y. Okay, and we have to get the equation of w as az plus b divided by cz plus d. If you get this equation, that is the bilinear transformation. Okay, we will be using this formula quite often, so remember this formula, and we will be writing the equation in this form to this form. Okay, if it is given a by b is equal to c by d, we can write the equation in this form: a plus b divided by a minus b is equal to c plus d by c minus d. Okay, so let's solve a question to make things more clear. Initially, we'll be given with 3 points: z is equal to z1, z2 and z3. Okay, so we'll be writing z1 value, z2 value and z3 value. Similarly, w's value will also be given. So w value is w1 is equal to 2, w2 is equal to I, w3 is equal to 2. The last values of z and w will be taken as z4 is equal to z and w4 is equal to w. After that, we have to apply this formula. Okay, this formula. In this formula, we will be subtracting w1 minus w2 into w3 minus w4 divided by w2 minus w3 into w4 minus w1. Okay, same thing we will be doing for z also, and we will be writing the equation in this form. Okay, after substitution of the given values, we will be obtaining this equation: 2 minus I into minus 2 minus w divided by I plus z into w minus z. Same thing we have done here also: 1 minus I into minus 1 minus z divided by I plus 1 into z minus 1. Try to simplify, take the minus sign outside from both of these, and you can cancel here. So, and try to arrange the terms in the same form. See, it's 2 minus I, so in the denominator also try to arrange it as z plus I. Okay, in the same form. Okay, after removing the negative sign, we will get 2 plus w, but in the denominator we have w minus z, so try to keep it as w plus 2. Okay, that will be useful in simplifying the equations. Okay, so let's see what we can do now. By componendo dividendo rule, we can have a by b is equal to c by d as a plus b by a minus b is equal to c plus d by c minus d. So a and b are nothing but the given terms here. This is a, this is b, and this is c, and this is d. So what we have to do, a plus b divided by a minus b. So what will be a plus b? This term plus this term, that will be in the numerator, and this term minus this term, that will be in the denominator. All you have to do is multiply this term in the numerator, add it with the multiplied term of denominator. Do the same thing, copy this here and just change the sign in the second part. Okay, same thing you have to do for c plus d and c minus d also. Okay, write these terms as a plus b and a minus b, and then multiply it once here and once here. Okay, and then you have to just add it in the upper equation and subtract in the lower equation. Okay, when you do that, you will get the following equations, and then you have to cross multiply it and separate the w and z terms. When you do that, you will get the w terms in the form of az plus b divided by c plus cz plus d. Okay, so this is the required bilinear transformation. After finding the bilinear transformation, most of the questions they ask to find the invariant points as well. So what's invariant points? In invariant points, you will do the same thing. It's very easy. See here, take the take this equation, and in this equation substitute the value of w as z. So you will get the equation z is equal to az plus b divided by cz plus d. Okay, and after that cross multiply and find out the values of z. Okay, by using the quadratic equation, you will get the values of z as I and 2i. Okay, which are nothing but the invariant points. Okay, coming to the third part, which is Cauchy's theorem and the numericals related to it. We have two theorems to prove, and we will be seeing the numericals for each of these formulas. Okay, so the first theorem is we have to prove integral f of z dz is equal to 0. So what is f of z? F of z is u plus iv. U and v are the functions of x and y. Okay, and it's given that z is equal to x plus iy. Therefore, dz will be equal to dx plus I dy. Okay, so f of z is u plus iv and dz is equal to dx plus I dy. We'll be using both of these equations in the place of f of z dz. In the place of f of z, we will write u plus iv, and in the place of dz, we will write dx plus I dy. Now we have to multiply these terms with these terms. Okay, when we multiply and separate the real and imaginary part, we will have the real part as this and the imaginary part as this. Now what we have to do, we have to apply a small theorem which is known as Green's theorem, which says if the integral is of the form m dx plus n dy, then you can write the same integral in the form double integration of del n by del x, second terms with del x, and the first term del m by del y, del m by del y. Okay, the first term with del y. So we'll be using the same thing here, and we'll be obtaining this. See, in this equation we have in the first part, the real part, u dx plus v dy. So this is m and this is n. M is equal to u and n is equal to minus v. Okay, so according to this theorem, it should be double integration of del n by del x. What is n here? N is minus v. So del of minus v by del x. Del of minus v by del x can be written as minus del v by del x. That's nothing but minus vx. That's what we have written here in the first part. Second part, we have minus del m by del y. What's m? M is u. So it will be minus del u by del y, which is minus uy. Okay, so I've written here minus uy and dx and dy in the standard equation. Okay, so this is about the real part. In the imaginary part also we have to do the same thing. See here, in this case m is equal to v and n is equal to u. So we'll be writing del n by del x first, which is del u by del x, which is ux, minus del m by del y, which is del v by del y, which is vy. Okay, and we'll have the minus sign in between, and dx dy. Okay, after this, it's given to us that f of z is analytic, so we can use the CR equations. Ux is equal to vy and vx is equal to minus uy. In the first place, we have minus vx, so we can use this value here, uy. Okay, minus vx is equal to uy, so here it will be uy minus uy. Similarly, in the second one also, we can use ux is equal to vy to get ux minus ux. in the both cases we will get as 0. So therefore integral f of z dz is equal to 0. Okay. Coming to the second proof, which is Cauchy's integral formula. In this proof we have to prove the following formula, and by for that we will be writing some theoretical points, which is with the point A we will draw two circles, okay, and in the first one we will have point A as the center and the radius r, okay, and we will have two circles. First one is C1 in the smaller circle and the second one is C, okay. And then we will be also mentioning the fact that f of z is analytic at all points except A, okay. If it's given z minus A, that means it's analytic at all points except A, okay. Therefore by Cauchy's theorem, the formula is applicable for both the circles C and C1. After that we have to take z minus A as r e power I theta. This is the standard formula. Therefore what will be dz? Dz will be I r e power I theta into d theta, okay. From here we will get the value of z. If we shift minus A to here, that will be A plus r e power I theta, okay. That will be using in this equation f of z. Instead of z we will write A plus r e power I theta, and dz will be substituted by the equation which we got here, and that will be I r e power I theta d theta, okay. And in the denominator we have z minus A, which is r e power I theta. These both terms will get cut from here and we will be remaining with I into f of A, since when r tends to 0, at that time r e power I theta will become 0, and we will be remaining with f of A and I from here, okay. So we will have I into f of A d theta. Since f of A is constant, we will take I f of A as common and we will be integrating d theta, which we will get as theta, and the limits are from 0 to 2 pi. So when we apply the limits, we will get 2 pi I into f of A. This equation is equal to this we got. If we take f of A as separate term and shift 2 pi I in the denominator, we will get 1 by 2 pi I into integral f of z by z minus A dz, okay. This for f of A. In case if we have f power n, means if we have f power 1 or f power 2, at that time we have to differentiate both of the terms with respect to A. We differentiate both sides with respect to A. That means when we differentiate f of A with respect to A, we will get f dash of A, and here we will be applying the Leibniz rule, which is 1 by 2 pi will be constant here, and here we will be differentiating partially with respect to A. So f of z will be taken outside and we will be differentiating 1 by z minus A partially with respect to A. That will be getting 1 by z minus A whole square, okay. So if we differentiate again, if it's f square, at that time we will get 2 by 2 pi I integral of f of z by z minus A whole cube. So there is a pattern here which can be generalized as, if it's given f power n of A, at that time we can write the general formula as n factorial by 2 pi I into integral of f of z by z minus A power n plus 1, okay. So if it's 1 plus 1, see, if you have been given with f cube, okay, at that time what will be n plus 1 here? N will be 2 if you write in the form of n plus 1. So here we will be taking 2 factorial and here we will be having cube, okay. So overall we have three formulas. First one is the Cauchy's theorem, second is the Cauchy's integral formula, and this is the general formula for higher values of n, okay. So for each of these formula we will be looking how to solve the numericals related to it, okay. So we have two parts here. First one is the Cauchy's theorem numerical, and the second one is the integration of Cauchy's theorem, okay. So in the first part, the type 1 question which can be asked is, points will be given, like suppose evaluate integral z square dz along the straight line from z is equal to 0 and z is equal to 3 plus I. You need to know what is the points in this case. 3 plus I means x plus iy. So the value of x is 3 and value of y is 1, okay. So the point is 3 comma 1, okay, and in the first case it's 0 comma 0, okay. So 2 points are given. We will draw a graph in the first step, and then we will be seeing the limits from where to where z is varying. Z is varying from 0 to 3i, that means x comma y is varying from 0 comma 0 to 3 comma 1, okay. By this we will get the value where from where to where x and y is varying, okay. X is varying from 0 to 3 and y is varying from 0 to 1, okay. After getting the points, we have to find out the equation of the line. How to find the equation of the line? Y minus 0 by x minus 0 is equal to 1 minus 0 by 3 minus 0. By that we will get the equation of the line y is equal to x by 3, okay. After that, the next step is to substitute the value of z as x plus iy in the given equation z square, okay. When we do that and substitute the value of dz as dx plus I dy and then multiply both of these, we will get the real and imaginary parts as separate. Okay. Now what we need to do, since we have dx and dy both, we just need one term, either dx or dy. So what you have to do is, by using the equation of the line, you have to substitute the value of y or x. Okay. So here I will be substituting the value of x here. X is equal to 3y, so dx will be 3 dy. So wherever you find x, substitute with 3y, and wherever you find dx, substitute with 3 dy. After doing that, we will have the equation of this form and the limits of y. Since we have taken the terms, all the terms in y, we have to see the limit of y. See where to y, see where y was varying from. It's from 0 to 1, right? So we'll be taking the limits as 0 to 1 and then simplifying the integration and applying the limits to get the final answer. This is of the type 1. Second type, they can ask you is, they can give you a square or rectangle, means they will give you 4 vertices and it will be either a square or rectangle. So the first step is draw a graph for it with the given vertices. Okay. So the 4 points which they have given, I will mark in a graph and then join these points in the clockwise or anti-clockwise direction. Okay. After that, you have to substitute the value of what equation they have given. It's given mod z. See what is mod z value? It's square root of x square plus y square. What is mod z square? That will be x square plus y square. Okay. So that's what we have to substitute in the given equation, and dz will be x plus I dy. Okay. See here, we'll have 4 cases. In the first case, the curve will be taken from O to P. Okay. In O to P, the x is varying from 0 to 1 and the y is remaining constant 0 to 0. Okay. Since it's a straight line parallel to x axis. Okay. So in this case, y is 0, therefore dy will also be 0 and x will be varying from 0 to 1. So we'll be taking only that integration part where x is there. Okay. See, mod z is equal to x square plus y square. Okay. So we'll have the integral of the form x square plus y square into dx plus I dy. In the first case, we have y as constant and dy is 0. Y and dy both are 0. Okay. So in this case, we can eliminate y and dy. So only terms which we have is x square and dx. So that's what we'll be writing here, x square dx in the integration form, and the limits from 0 to 1. Similarly, in the second case, observe here, x value is constant as 1. X is 1. Since x is constant, dx will be 0 and y is varying from 0 to 1. So the limits of y will be 0 to 1 and we'll have dx as 0. So the remaining term will be I dy only. Okay. So in the equation of x square plus y square into dx plus I dy, in this case x term will be taken as 1, so it will be 1 square plus y square, and here dx is 0. So the term which we get is 1 plus y square into I dy and the limit from 0 to 1. Okay. So that's the second equation. See here, 1 plus y square into I dy and the limit from 0 to 1. Similarly, for the third and the fourth one also you have to do the same. Here y is constant and here x is constant. If x is 0 or x is 1, you have to substitute that, and whenever a value is constant, that differentiation means dx will be 0, or if y is constant, at that time dy will be 0. Okay. Make the substitutions accordingly and add the four terms in the final equation and apply the limits to get the final answer. Okay. The third type of question can be of a t as a parameter of x and y. Okay. So in this case, we will be given with this equation and we will be given the value of x and y in the terms of t. Okay. So what we have to do is, we have to find out what is dx and dy in terms of dt and then substitute either x as t or y as t. Okay. You can choose any of that and then make all these terms which are given here in the terms of t. Okay. So what is dz here? Dz will be dx plus I dy. And dx value in the terms of t is found out here, dt and 4t plus 4t dt. Okay. So by using these two equations, we will be finding out the value of dz and substituting the values of x and y as t, and the limits will also change. We have been given with the limits 1 minus I and 2 plus I. By this you need to know what is the value of x and y. In this case the point is 1 comma minus 1 and here the point is 2 comma 1. So the value of x is 1 here and 2 here. So by using the values of x as 1 and 2, find out the value of t. See, t can be written as x minus 1 by using this equation. So when you substitute the value of lower limit wherein x is 1, at that time you will get t as 0. And in the upper limit, when you substitute the value of x as 2, you will get 2 minus 1, which is 1. So the limits of y are t is equal to 0 to 1. Okay. See here, when x is 1, t is 0, and when x is 2, t is 1. By using the equation t is equal to x minus 1. Okay. And after that we will be substituting the values of x, y in terms of t and dz in terms of dx and dy, and further substitution of dx and dy will give us the terms in dt. Okay. After that just multiply each of these terms and find out the real and imaginary parts and apply the limits to get the final answer. Okay. It's just the simplification part. Okay. Coming to the Cauchy's integral formula, we'll have two types wherein the question will be of this form. Will be given with some value in the numerator, and in the denominator we'll have one or multiple terms. Okay. So here we have z minus 1 and z minus 2. So what you have to observe is z minus a and z minus b. So the values of a and b are 1 and 2. When you get this, first check the value of z which they have given. It's 3. The values which we get here should be less than 3. If it's greater than 3, suppose we got here 4, at that time it's lying outside the circle and the value of the integral will be 0, and we'll be seeing an example in the upcoming problems. Okay. So in this case we have the value of a as 1 and b as 2, which is less than 3. So it's a valid point since it's lying inside the circle. And after we get that, we have to separate these two terms by using the partial fraction, find out the values of a and b, substitute it and find out the integral separately. This is of the form f of z by z minus a integral. Okay. The equation of this is, which we found out earlier, it is 2 pi I into f of a. Okay. So here a will be whatever the value that we will be using in f of a. Okay. So we will be writing each of these term in this form. Okay. So the first term will be minus e power 2z divided by z minus 1. So a value is 1 here. So what we will be doing is minus 2i, the minus from the previous one, and 2 pi I into f of a. What is f of z here? F of z is e power 2z. See here, it's given as e power 2z. So instead of z, if you have to apply a, we will be getting e power 2a. The value of a is 1 here, so we will be getting e power 2 into 1. Okay. So this value will be substituting in the final equation, which is minus 2 pi I into f of a. The value of f of a we found out, which is e power 2, and similarly we will do the same thing for the next one also. In this case a is 2 here, so f of 2 will be e power 2 into 2. Okay, that is e power 4. So we'll be substituting the same thing here. We'll be taking the common term separately to get the final answer. Okay. Coming to the second question, we have been given dz by z square minus 4. Z square minus 4 can be written as z plus 2 into z minus 2. So what are the values of a and b? A value is, see here, it can be written as z minus minus 2. So the value of a is minus 2, and from here the value of b is 2. So the value of a can be written as minus 2 comma 2. See, these both points lie outside the circle. Why? Because mod z should be less than 1. What is mod z here? Mod z in both cases is 2, which is greater than 1. Okay. Whenever we get a value which is greater than 1, we have to write that the given points are lying outside the circle with radius 1. Therefore the value of the integral will be 0. Okay. In the third question, we have been given with a formula which is slightly different than the previous ones. Here we have z minus 1 whole square. That means we have to use the n plus 1 formula. Remember, we had discussed in the proof z minus 1 power n plus 1. So here n plus 1 is given as 2, so n will be 1. Okay. In the previous cases, we just had the denominator in the terms of powers of 1, but in this case we have the power of 2. So you have to use the generalized formula. What's the formula? This is the formula, f of z by z minus a power n plus 1. If it's given n plus 1, at that time we have to use this formula. Okay. So according to this formula, f of z is z square minus z plus 1. Therefore 2 pi I, and the value of n is 1 here, because 2 is written as n plus 1. Therefore n will be 1. we'll be having n factorial as 1 factorial and f power 1 of a. What is f power 1? See here, f of z is given as z square minus z plus 1. What is f dash of z? F power 1 is nothing but f dash. F power 2 is f double dash, like that. Okay, f dash of z means differentiate the f of z with respect to z, we will get 2z minus 1 and substitute the value of z as a. In this case a is 1, therefore 2 into 1 minus 1, which will give us the value 1. So f dash of a is 1 and we will be using that value in this place. Okay, so when we substitute 1 here, we will get the final answer as 2 pi I. Okay.